So the next part of this website is talking about the cardiac axis. Now, first of all, what is the cardiac axis? Well, it's the major direction of electrical activity through the heart. Specifically, this is during ventricular depolarization. In other words, it's the main average vector that happens during the QRS. What we've been doing so far is looking at lots of different vectors that make up the QRS. There's, over time, it starts off going in one direction, then goes down the main apex for a long time, and then finally does that tiny little flick up to the left ventricle. What we've been doing there is almost looking at these dots. We've been taking small vectors over time. Now, what the cardiac axis is essentially the line of best fit through the QRS complex and saying, right, was that mainly positive? Was that mainly negative? And from that, we can say what kind of position the heart is sitting inside the chest. We can say whether there's a certain part of the heart that is requiring more electrical activity. So, for example, in left ventricular hypertrophy, that left ventricle would be a lot thicker, so it takes a lot more electrical activity in that area to cause the full thickness of the heart to depolarize. So then the more electrical activity we have to go in that direction, the vector will be skewed to the left-hand side, and that can help you indicate pathology. So what I've got here is just the fact that we know that for ventricular depolarization, we're looking at the AV node, and that major vector is traveling towards the apex. So a bit like this. So what we're going to do now is try and apply that to the graph that we've been looking at all this time. So what I've done is just drawn an arrow over the top of that just to say that is the average vector for the QRS complex. And I'm just going to copy and paste that and stick it on this graph here. So there's many ways you can work out the cardiac axis. The way I do it is using lead 1 and lead AVF to pinpoint the location like an X and a Y axis. I've left leads 2 and 3 on there because there are other ways using leads 2 and leads 3 to figure out where it is, and I'll go into that when we get to it. So all I've done is copy and paste this arrow onto here, starting at the center, going there. So let's see how far across lead 1 it went. It went that far across. Let's see how far across lead AVF it went across, there. So we can see that went to the positive end of lead 1, the positive end of lead AVF. So if we think what would the ECG look like, we know that it should be pointing, the QRS in lead 1 should be positive, the QRS in lead AVF should be positive, but you can see it actually goes down quite a bit further on the positive AVF line than it does on the positive lead 1 line. So I make a guess that the QRS in AVF will be much taller than the QRS in lead 1. And let's see the ECG from that. And that's exactly what happened. So we can see here's the QRS in lead AVF, quite tall, in comparison to the QRS in lead 1, much smaller, but they are both positive. That fits in with this diagram here. Normal axis is considered within this red boundary here. We can see it goes from, if this is 0 degrees here, it's from minus 30 degrees. That's the line of the positive AVL lead. And it also goes all the way down to positive 90 degrees there, which is in the same line as lead AVF, the positive end of lead AVF. So we can see that our average vector sits nice and easily in that normal boundary, so it's normal axis. But unfortunately, we're not given someone's main vector of the QRS and told to work out what it would look like on an ECG. We have to do that whole process in reverse when we're looking at someone's ECG. We're given this, and we have to then work backwards to see what the axis looks like. So let's give that a go here. So I'm going to look at leads 1 and leads AVF here. You can see that lead 1 is very positive. It's quite tall as well. So we know it's somewhere along this positive end of lead 1. So we don't know whether it's pointing in this up direction or down, but we know that it's pointing in the direction of positive lead 1. Let's look at ABF, which, let's take this QRS here. It's very negative, maybe almost exactly the same height as the lead 1, maybe slightly smaller, not very much, but it's almost, it's very negative, negligibly positive, definitely negative. So we're going to be somewhere along the negative part of ABF. You can see these two lines have now crossed. That means the vector is pointing towards where they cross from the centre. So let's see whether that's in the normal range. No, it's left axis deviation because it's deviated from the normal round to the left-hand side and it's outside this normal boundary. So this patient has left axis deviation. There's now going to be a PowerPoint underneath with some more questions for you to see whether you can test this knowledge of cardiac axis.